Good afternoon, everyone. I am Izumi Mai of Toho University. Today, I would like to introduce you to green sustainable chemistry, which is extremely important in the field of chemistry. GSC might be a term that not everyone is familiar with. In English, GSC is an acronym for Green and Sustainable Chemistry. It refers to an approach in chemistry that is friendly toward people and the environment, and supports the development of a sustainable society. It represents a very important viewpoint in the study of chemistry. Here, I shall explain in detail exactly what this means. For example, every stage in the life cycle of a product, right from the selection of raw materials, followed by its manufacturing and transporting, to the stages where the product is used and disposed. The product has an impact on the environment. We evaluate this impact at every stage. In the past, the focus was only on the manufacturing of the product. However, as we see in this figure, if we do not have an overall understanding of a product, from the selection of raw materials to its disposal, and if we do not consider its environmental impact, we might not be able to determine correctly the burden chemical products and engineering place on the environment. Thus, a new way of looking at and thinking about chemical products has emerged, in which the environmental impact of products throughout their life cycle is evaluated. This is called life cycle assessment. This way of looking at and thinking about products is reflected in the GSC evaluation. Now, let us take a look at some methods of dyeing that are familiar to everyone. This is cochineal, a scale insect, the techniques for dissolving them in water and using them to dye threads and textiles have been in existence worldwide for thousands of years. However, in the latter half of the 20th century, there has been a shift from the use of natural dye to synthetic dyes, which means that a lot of water, energy, and chemical products are now being consumed. This calls for a need to rethink our dyeing methods. Therefore, the use of no-water dyeing method is required. This is the headquarters for Innovative Society Academia Cooperation at the University of Fukui. Here, Dr. Teruo Hori has worked for many years on researching and developing dyeing methods that do not require the use of water. This is an experimental dyeing machine which uses supercritical carbon dioxide to dye textiles. Why did he consider the dyeing method using no water? Dyeing textiles requires excessive use of water. This is unfavorable for law-tech industries, as the water that has been used contains dyes and various chemical agents and must undergo proper liquid waste treatment. Thus, I have conceived of a method of dyeing using carbon dioxide, which neither requires the use of water nor produces wastewater. Why did he use carbon dioxide specifically? Now, everyone knows that substances exist in three states: solid, liquid, and gas. In the case of carbon dioxide, when its temperature is 31.1 degrees Celsius and it is under pressure of 7.4 megapascals or more, it surpasses its critical point and enters the state of supercritical fluid, in which it has intermediate properties of liquid and gas. Therefore, Hori used the supercritical fluid. This is a perforated tube around which a polyester textile is wound prior to dyeing. Here, we will dye the textile. First, a red dye is prepared. The dye is then placed in a dissolving tank. After this, the textile to be dyed is placed in a processing tank. Carbon dioxide is then fed into the tank. The tank is set to a temperature of 120 degrees Celsius with 25 megapascals pressure. Carbon dioxide is then circulated inside the sealed processing tank. In this process, the textile gets dyed efficiently. With this method, the carbon dioxide can be used multiple times, as it is not expelled into the environment after every use. In addition, this process does not generate any post-dyeing liquid waste, which makes it an extremely environment-friendly and energy-saving method of dyeing. After 1 hour, the textile is removed from the processing tank, and we see that it has been dyed a vivid red. Using carbon dioxide in its supercritical stage helps swelling the textiles, which makes it easier for the dye to enter the fabric. Thus, the process of dyeing can be completed within a short amount of time. This method of dyeing has come to be used in various countries such as Thailand. The use of supercritical carbon dioxide might not be very different from traditional dyeing methods. This uniform consists of a T-shirt produced by a sporting goods manufacturer. The manufacturer claims that this method was specifically adopted because dyeing methods using supercritical carbon dioxide are people and environment friendly, and this seems to improve the company's image as well. Let us now review the merits of supercritical fluid dyeing methods. Does not require auxiliaries to improve dyeability or prevent uneven dyeing. Shortens dyeing time. Dyes that do not exhaust to fibers are recovered in powder form. Requires no drying processes. Produces very little liquid waste. In other words, it is environment-friendly. Next, let us compare the differences between conventional dyeing methods and supercritical fluid dyeing methods. In conventional methods, an excessive amount of water is used for dyeing and other subsequent processes. This results in the discharge of polluted wastewater. In addition, the process of drying consumes excessive amounts of energy. On the other hand, no water is required during dyeing, so no polluted liquid waste is produced. In addition, since there is no requirement for drying, no energy is utilized for this process. Thus, using a supercritical fluid dyeing method means using less chemicals, no liquid waste or fumes, and reduced energy costs. This method is not just environment-friendly, but also allows for the manufacturing of better products at lower costs, and therefore should be promoted in society. Thus, we see that GSC proves to be beneficial in 3 areas: the environment, society, and economy. While I introduced the supercritical fluid dyeing method in this presentation, another dyeing method that is gaining popularity is inkjet printing. I believe we will see further development in dyeing method using new technologies from an ecological perspective. Thus, we have reached the end of this presentation. I hope that you have gained an understanding of green sustainable chemistry, which is environment and people-friendly and supports the development of a sustainable society. I believe that going forward, looking at things from the perspective of GSC will be very important.